Let's talk about chemical composition, and hopefully this is going to be one of those shorter lectures that's just a quick review from chemistry. So when we talk about chemical composition, we talk about physical properties, and physical properties of a mixture depend on chemical composition. So how this solution looks, like what color is the liquid that you mix together, that's a physical property, and it depends on its chemical composition. So some important terms that you're going to want to know and you're going to want to remember for this class. The first is atomic weight. And so atomic weight, if you remember from your chemistry courses, the mass of the atom based on assigning carbon-12 a mass of exactly 12, right? So atomic weights are where? They're on the periodic table. So you do need a periodic table for this class. We do chemical kind of style problems because we do deal with chemicals quite often as environmental engineers. So it's important to remember this atomic weight. The other one that is important is molecular weight. So if we think about just an atom, something like maybe arsenic. Arsenic is an atom by itself, but if arsenic is combined with other compounds or other elements, you can make compounds. And compounds are many times called molecules, so we use molecular weight. And this is the sum of atomic weights of elements that are in that compound. So you use the periodic table to calculate molecular weight. So we use something called a gram mole. And that is the amount of species whose mass in grams is numerically equal to its molecular weight. So, for example, carbon monoxide has a molecular weight of 28 grams, which means that 1 mole of carbon monoxide therefore contains 28 grams. So, where did that number 28 come from? If you look at the periodic table and look at the atomic weight of carbon, it's 12 grams per mole. If you look at the atomic weight of oxygen, it's 16 grams per mole. If you add those two up, the molecular weight of carbon monoxide must be 28 grams per mole. So that means for every 1 mole, 28 grams. That's what this sentence means right here. And then something that's really important is that your molecular weight, or MW as I'm going to abbreviate it in this class, is used to convert between mass and the number of moles of a substance. Star this, highlight it, whatever you need to do to remind yourself that this is important. Mass cannot be created or destroyed. And when we're talking about solutions, the number of moles is conserved over the entire solution in the system. So as we start to talk about different compounds interacting with each other in a mass balance, you're going to need molecular weight to be able to go between mass and moles. And this is super, super critical. So to finish out this video, let's just do a real quick example. It's on the top of your next page. How many kilomoles are there in 34 kilograms of ammonia? Apologize. There's this page on the screen. Pause the video. See if you can do this. See if you remember this from chemistry. Did you pause the video? Hopefully you did. So if you remember from chemistry, when you have something like grams per mole, you can also have kilograms per kilomole. So don't worry about converting from kilomoles to moles and kilograms to grams if both of them have the kilo prefix. So just remember that. So if you take 34 kilograms of ammonia, which is NH3, if we want to know how many kilomoles there are, we're going to multiply by the molecular weight, right? So this is the molecular weight right here. So molecular weight, if we want to get rid of kilograms, kilograms must be on the bottom, which means kilomoles must be on the top. And if you're pulling anything from the periodic table is in terms of kilograms per kilomole. So that means this number for kilomoles is 1. Now, if you go to your periodic table, nitrogen has an atomic mass of 14 kilograms per kilomole, and you have 3 hydrogens, which each of those has 1 kilogram per kilomole. So your total molecular weight here is 17 kilograms per 1 kilomole. So what that is going to do is that is going to give you an answer of 2 kilomoles of NH3. So just remember how to convert between something in grams to something in moles. It's always using molecular weight, and that's super important. And then sometimes, this is just kind of a side note to see how much you remember about chemistry. The number of moles is not the same as the number of molecules in a system. So we know that 1 mole of any species is going to contain 6.02 times 10 to the 23rd molecules of a species. And this is what's called Avogadro's number. We don't worry about it as much as we do in chemistry, but on occasion we do want to know molecules instead of moles. So this is your conversion factor to get to there. And that's where we're stopping in this video. The examples that come next are things that we're going to talk about in class. So if you want to look ahead just to get a sense of what's going on and what's going to happen next, take a look over those. We will go over these in class.